Hello everybody, welcome to my channel. In this video I will talk about a common fault in Parker IOTA One solenoid valve controller and how to repair it. Since you are watching this video, most probably you know what a Parker IOTA One controller is, so it's doing exactly what is called, so it's driving a solenoid valve. And this type of controller is designed specifically to drive very fast some Parker valves, so Series 9 and Series 99. The controller looks like this. So this is the old version. I'm quite sure that you recognized it immediately. So this is old version. Here is the new version. The way it works is the same. It's just the new version can be connected to computer via serial port, and it looks a bit fancier. But it doesn't mean that it's better. I would rather prefer the old version because it's working better when you have a very noisy environment. Electrically noisy. So when you have an strong electromagnetic pulse, this one behaves better than this one. All right. So what is the problem with or what can be the problem with this type of controller? So the problem comes from two different sources. So I call it in one case, so the one that you can see here on the left, I call it user stupidity, and on the right side I call it the honest mistake. So what do I mean by user stupidity? The Parker, the IOTA One controller is supposed to work only with this type of valves, so Series 9 and Series 99, which they have a certain impedance. Now the problem is many users, they try to use whatever solenoid valves they find in the lab. And of course, these ones, they have a different resistance or impedance. They require probably a different current. So what they do, they overload the controller, and the controller just dies. And the second case, the honest mistake case, what is very common if you are using in laser wake field acceleration experiments, the electromagnetic pulse can be really strong, and if you place the solenoid valve very close to the interaction zone, then the EMP goes through the wires. Sometimes or quite often can burn the valve, so inside there is the coil, so that can be destroyed. Or in some cases it can go through the wire to the controller and also kill it. So but the thing is, even if the controller is killed, it can be revived quite easily, or in general quite easily. The most common fault, so here you can see the interior of the controller. So this is for the old type of controller. This part is moved here on the front panel for the new version, but the rest of the stuff is pretty much the same. So I have the power supplies, which are here. Here are the mains, and here is the most important part of the controller, which is the driver, the solenoid valve driver. And here you have the part that controls the opening time of the high voltage part, and here you can set up the voltage for the holding part of the signal. So 28 volts, 24 volts, and so on. So depending on the valve. But what I want to talk about, so most often when the driver stops working, the solution is to the solution first, of course, is to check the fuse, which is here, and replace it if it's the case. And the next, check these diodes that you can see here. So these are just rectifier diodes. It's not very common, but sometimes it can happen. But most of the time, the problem comes from these MOSFETs that you can see here. And also you have a diagram in case you want to know more details. What kind of MOSFETs we have there. So those MOSFETs are here. So these two here. And all you have to do is measure and find which one is dead. It can happen that one or two, or both of them are dead, so you just replace them, and that should solve the problem. I encountered quite many times this problem, and every time this was the here you can find the fault. So rather than buying a new controller, which can be quite expensive, it's easy to just replace these MOSFETs. I think that's all, and if you have any questions, you can leave them in the comments or contact me in private. Goodbye, and see you next time. Bye.